Welcome!
Welcome.
Welcome
Welcome to
G.
X
K.
and tutorial.
Without further ado, let's name a type 1 binary compound.
For lithium oxide, we have lithium and oxygen. Lithium has a 1 charge and oxygen have a negative 2 charge. I can change the subscript to each side to make it balance. And we can check using the crisscross method.
And that's it. We get the lithium oxide formula.
Let's now move on to naming type 2 binary compounds. The rules for naming type 2 are quite similar to type 1. Like in type 1, cations goes first and ion second. Cation's name stays neutral but will have Roman number for oxidation level alongside. Anion's root name will be added suffix IDE. And lastly, writing the name by combining the ions. Try this example, TiO2 negative charge. Binary compound, titanium and oxygen. Then, we will identify the cation and the anion. Then, proceed with the crisscross method. Now, since oxygen is a diatomic element, it will be times 2. O2 negative charge of ion. Then we will have negative 4 times 1 is equals to 4. And we will get an answer of titanium for oxygen. After identifying the Roman number for oxidation level, add the suffix IDE. So, we will have titanium for oxide. And that's how you name type 2 binary compounds.
In this part of the video, I will be teaching you the type 3 naming. So, to begin with, let us have N sub 2 and SE sub 3 for the given. And then, the first thing that you need to do is to identify the element for the given symbols. And the symbols that we have here are obviously the letter N and the letter SE. And then, determine the supposed prefix for the subscript. And the subscript that we have here is the number 2 and the number 3. So, let's start with N sub 2. The element for the symbol letter N is nitrogen. And the prefix for number 2 is di. So if we combine both of those together, we will have dinitrogen. Next, let us have the Se sub 3. So Se stands for selenium, and the 3 is tri. If we combine both of those together, we will have triselenium. But, on the other hand, it should be called as triselenide because this belongs to the binary compounds. That is why we need to replace the IUM with IDE. So, selen plus IDE is selenide, and then add the prefix tri, we will have triselenide. And the last step is to combine the two, which is dinitrogen and triselenide, and then we will have dinitrogen triselenide as the final answer. So, in addition to that, we should always remember to read the subscript first before the name of the element. So instead of saying nitrogen di and selenide tri, we will name it as dinitrogen triselenide.
In this video, I will teach you how to write a formula of polyatomic ion, and we need periodic table and polyatomic ion list. So let's try this example: aluminum hydroxide, So for the first step, we need to find the charge and the symbol of aluminum and hydroxide. So for the aluminum, it's Al and the charge is 3 plus, while the hydroxide is OH and the charge of 1 minus. In second step, all we need to do is to balance the charge, and we have Al3 plus and OH1 minus. So we need to add 2 more hydroxide to balance the charge. So let's add 2 OH1 minus. So we have 3 plus and 3 minus charges. So for the last step, we need to write Al alone because we need only one aluminum, and for the hydroxide we have 3, so we need to multiply 3 in hydroxide. So write OH and put parentheses and write 3 because so in naming this formula, all we need to do is find Al in periodic table, which is aluminum, and OH in polyatomic ion list, which is hydroxide. So naming and writing the formula is very simple.
Let's talk about acids. But what is an acid? Acid, a compound in which one or more H positive are bonded to a negative ion. So, I got an example of a common acid, and we can break its acid down into H positive part and negative ion part. Any ionic formula, the positive charge and the negative charge has to balance out. That means the balance of the H positive equals the charge from whatever the negative ions. In this case, we have positive 1 for H, negative 1 for F. When we are naming an acid, the name of an acid is based on the name of the negative ion that is part of the acid. We gotta figure it out what the name of the negative ion is. And based on the name of the negative ion, we can figure it out once we write the name of the acid. Let's try this example. HC2, H3, O2, negative charge. So this is also similar with C2, H3, O2, negative charge. So we should figure it out what the name of this ion. So we are gonna use this table. And based on the table, we call this acetate. So we are gonna use this rule. We can see it ends with ATE. So we take off the ATE and place it with IC. And we are gonna add acid. So we are gonna call this acetic acid. So that's how we name acid that contains ions that ends in ATE. We take off the ATE from the negative ion name and we put IC, add acid, acetate, goes to acetic acid.